Okay, so this is kind of a weird idea. You're only probably going to use it in an Algebra 2, a college algebra class. However, if you remember this fact that I'm going to show you, it can help in other classes. So it says, find the discriminant of each quadratic equation, then state how many and what type of solutions. So here's what we mean. I'm going to show you three graphs. Well, one quadratic might look like this. So those are two real numbers, two real roots. Now they could either be rational, meaning fractions, integers, or irrational, where they have a square root in them. Then you might have a graph that looks like this, where it sits only on one place, and that is one rational root. You don't even have to say, I mean, it is real, but we know for one rational root. There will be no square root in that. It'll just be one rational root. Then you've got graphs that don't touch the x-axis. Well, those are two imaginary, called complex roots. All right, and how you know about those, hopefully I just didn't erase what's underneath. I didn't. So when you're taking the quadratic, if you just set up this part, ignore the radical. If you type into your calculator, parentheses b squared minus 4 parentheses a parentheses c, you're going to get a value. If that value is 0, that's the example where you're going to have one rational root. If when you do this piece right here, and you get a positive number, or a number greater than 0, this is the example of that graph. You'll have two real, but they'll either be rational or irrational. They're irrational, they have a square root as part of the answer, all right? But a square root is still part of the real number system. And then finally, if you have a negative number or less than 0, if when you do this, you get, say, -5, that means the discriminant is less than 0. You will have two complex, because remember, -5 is the same thing as square root of -1 times 5. Square root of -1 is positive -I. So if d is equal to 0, one rational root. If d is greater than 0 or a positive number, two real roots, either rational or irrational. And if the discriminant is less than 0, two complex roots. So let me go ahead and erase all this. So we first have to get the number on the left side over to the right. So -8 plus 8n, subtract 2. Here's our A, our B, and our C. And that's what we're going to plot. So we're going to say the discriminant is B, so there's our 8 squared, minus 4 times, our A is -8, our C is -2. So when you type that into your calculator, let's see what you get. You get 0. Remember, if d is equal to 0, it's going to look like this. So that's one place, and that will be a rational number. No square roots, because it sits right on the x-axis. All right, let's do this one. So add 7. So our A is 6, our B is 7, and our C is 0. So when we say discriminant equals B squared minus 4 times A times C, well, these three are 0, so 7 squared is 49. Well, that's a positive answer, so that means it's one of these examples. In fact, this one, positive and negative 7, probably. Well, no, there'd be other stuff. But that means that there are going to be 2 either rational. Well, in this case, since that's a perfect square, that will be 2 rational reals. If this would have been, say, 53, that would have been 2 irrational reals. So if it's a perfect square, 2 rational reals. If it's an imperfect square, 2 irrational reals. All right, and then finally, let's look at this one down here. So we're going to add 8 to both sides. So now we have 2n squared subtract 1n subtract 2 is equal to 0. So when we put the d in, I'm gonna change this to red. D is equal to b negative 1 squared subtract 4. Sorry, I just had to pause because I just sneezed. 2 is the a, c is the negative 2. When you put that in, that will be 1. This negative times this negative is positive. 4 times 2 is 8, times 2 is 16. You get d is equal to 17. That's an imperfect square. So it's positive, but it's an imperfect square, so this one will have 2 irrational reals. All right. And I did not do one where, did we do one where there was a negative number? Maybe that first one. I don't know. So, well, here, let me do this. Let's say, just for argument, since I probably didn't do an extra one, d is equal to negative 17. When you take the square root of negative 17, that's the same thing as negative 1 times 17, and I comes out. That would be an example of 2 complex roots. And that's the example where it might be up here, or the graph might be down here. When they're complex roots, the graphs will never touch the x-axis.